Welcome! In this video, we are going to be looking at degrees and radians in a circle. We will also be converting degrees to radians and radians to degrees. So let's start off with two basic facts that were covered in a previous video in my lecture series. There are 360 degrees in every circle. That is if we look at the circle in terms of degrees. We can chop up that circle into 360 individual degrees, or decimals or fractions or partial degrees if we wanted to. Another way to look at the circle is in radians. A radian is 180 degrees, and 2 pi is 180 degrees, or 360 degrees. So 360 degrees in one circle, or 2 pi radians in one circle. Both of these are equal to each other in terms of measurement. And we're going to be using that 360 degrees equals 2 pi to do conversions later on. Because what we can do is we can solve for degrees by putting down 360 degrees is equal to 2 pi. And then what we do is divide both sides by 360. So 1 degree is equal to pi over 180. We can also do the same thing here. We can solve for radians. So if we have 360 degrees is equal to 2 pi radians, we can divide both sides by 2 pi, and therefore we get 1 radian is equal to 180 degrees divided by pi. We will use these conversions later. But for now, let's just kind of leave that alone and do just some quick measurements, and these measurements will actually be free-handed. So in this grid, we're going to free sketch 60 degrees, 120 degrees negatively, and 540 degrees. And then we're going to sketch 4 pi over 3, negative 2 pi over 3, and finally 21 pi over 4. Now, first of all, let's talk about how we begin our sketch. We're going to begin our sketch at 0 degrees or 0 radians. And since this is going 60 degrees, we will be going in a counterclockwise fashion through quadrant 1 of our 4-quadrant system here. And this t, this theta angle, will be 60 degrees. Now, if we decide to go 120 degrees, but go negatively, we are going to start here at 0 and go negative 120 in this direction, in the clockwise direction. Now, the counterclockwise direction, 120 degrees, as you've seen on some partially completed unit circles in previous videos, landed in the first quadrant about right here. So 120 degrees will go 90 degrees here, and then an extra 30. So 90 plus 30 makes about 120 degrees. So this is our angle T right here. Now, the book uses T, and some books use the Greek letter theta, so it's kind of fitting that they use the letter T here. Now, if we're going to go 540 degrees. Now, 540 degrees is bigger than 360 degrees. In fact, we can take the 540 degrees, subtract the 360 degrees, and get a total of 120 degrees, which means that this is going to go around the unit circle once, and then go 120 degrees further. So this goes to 90 degrees and then an extra 30, and so that makes our angle T right here. Now the angle T could be written inside here if you wanted to, or the outside. Wherever you put your angle T, it just is this continuous spiral, 360 plus 120 to get to 540 degrees. So we're going to look at some radians now. Now it is helpful to have some of our previous worksheets here where we've looked at radians and how big radians are compared to a unit circle. Now, let's actually just kind of investigate right now just pi. Pi is 180 degrees, so this is pi radians. You can now see that if I take another pi, that would complete a full circle. So that starts off our video that we had a circle is equal to 2 pi. But let's kind of jump ahead a little bit and do a little bit of conversion. Now, one of the ways that we can convert from degrees to radians is use this equation. By multiplying by 180 divided by pi. This will convert your radians into degrees, because the pi's will simplify to 1, and you can divide 180 divided by 3, and 180 divided by 3 is going to give you 60. And 4 times 60 is 240 degrees. There's nothing wrong with converting from radians to degrees if it would help you do the problem. 240 degrees from 0 degrees takes you all the way over to this mark, which happens to match our graph number 2 up here. It matches graph number 2 because this was negative 120 degrees and this is positive 240 degrees. So the terminal side of this angle is in the same position as in the problem or the graph number 2. Let's convert to degrees again for this one. Now again, if you have a completed unit circle, you can actually literally go to this and see where it is on the unit circle. And feel free to do so. You don't have to do the conversions that I'm doing if you have your completed unit circle from one of the first videos that we've done together in class. So if you were to do the conversion from degrees to radians, there you go. You just have to multiply by 180 divided by pi. The pi's simplify to 1. 180 degrees is divided by 3. And 180 degrees divided by 3 is another 60. And so here we have negative 120 degrees, which we've actually graphed in problem number 2. So here's another copy of problem number 2's angle T, where the terminal side of this angle is in the third quadrant. Okay, so number 6 really puts the problem in the pinch on right here. I would suggest that we try to convert this into degrees to make this the easiest possible. You'll see that 21 pi over 4 is way bigger than a unit circle. So I want to show you how to convert this into degrees first, and it wouldn't hurt to have a calculator right by your side, because if I divide the pi's, which is pretty straightforward, I also can then simplify the 180 divided by 4. 180 divided by 4 gives me 45. And then what I have to do is I have to take the 45 and multiply it by 21. Now 21 times 45 is 945 degrees. Now that's where you probably want your calculator, not only for the 180 divided by 4, but for the 21 times the 45. So now that we have 945 degrees, it kind of like makes me think like, well, how many circles are actually in 945 degrees? So what you should do is you should maybe divide the 945 by 360, and you see it's a decimal of 2 point something. What's important about that, it means that 2 full unit circles will fit inside of the 945 degrees. Well, let me say that again. If you take your 945 degrees and divide it by 360, you get 2 point something, which means that there are 2 full unit circles within inside of 945 degrees. If you're pulling off a skateboard trick, you have done 2 complete revolutions in a 945 degree angle. Now, this gives you 720. Subtract the 720 from the 945, and you get 225. And 225 degrees is within 1 unit circle. So let's start drawing this thing. So what we found out is that this 945 degree angle, or 21 pi over 4, is 2 full circles. So it's 1 and 2. So that's 2 full unit circles. And then what we have to do is we have to go 225 degrees. Now, there's a couple ways we can do this. One way we can do this is we can look on our example and see where is 225 degrees. Like you have in previous videos marked out these distances. So what I suggest though is I suggest maybe you should go to 225 degrees by breaking that up into maybe 180 degrees. So take, whoops, didn't mean to move up the worksheet a little bit. So take that 225 degrees and make that 180 plus 45. Because that takes us from here to the 180 degrees plus another 45 degrees takes us right here to the terminal side in the third quadrant. So this, wherever you want to put your letter T, shows you the full spiral of 945 degrees, or 21 pi over 4. Another way you could have done this problem without actually converting this is to realize that a pi over 4, so let's just look at just pi over 4. Pi over 4 is 45 degrees, or takes you about right here. And what we could do is count this 21 times. So this would be 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 pi over 4. And then you can see that going 16 pi over 4 would take me another revolution. So here is 8 pi over 4, 16 pi over 4. And then 17, 18, 19, 20, and 21. So this takes me all the way here, which is exactly where I ended up converting to degrees. So that's another way to do it without converting to degrees and just using the fact that a pi over 4 is 45 degrees, or halfway between here and 90, and we have 21 of them. Okay, so we are going to take, now we have just finished examples of converting radians to degrees, so let's convert degrees to radians. Now we're going to make sure that we express our answer as a multiple of pi. So the formula is you take your degrees, whoop, I made a mistake there, gotta spell correctly. Good thing I teach mathematics and not English. So take your degrees divided by 180, and that's equal to the radians divided by pi. So if you're going to convert from our degrees to radians, we're going to multiply by pi over 180. And that is going to mean that the pi is going to come up here into the numerator, so we can get our degrees into the radians position. So simplification, absolutely. We can divide this and this by 60, and in doing so, this would become a 2 and this would become a 3. So this is 2 pi over 3. Now some of you have noticed that, hey, Mr. Anderson, in a previous video, we actually had 2 pi over 3 marked on the unit circle, and I could have just seen that at the 120 degree mark, it's 2 pi over 3. Yep, that's exactly right. You can do the same thing for the next one too. 330 degrees is very common and it's on the unit circle, but in case you want to do the conversion with me, this pi over 180 degrees, you could get your simplification by dividing by 30 right here. So if you divide the top and bottom by 30, right? So, whoops, I don't need to write 30 at the top there. That's just silly. Okay. So if I divide this by 30, I have 6 in the denominator, because 180 divided by 30 is 6, and 330 divided by 30 is 11. So our answer here is 11 pi over 6. Now, again, these two examples, 7 and 8, were on your unit circle that you've had in your notes since session 1. So let's look at a problem that isn't on your unit circle. This is negative 25 degrees. Let's multiply by pi over 180. Well, what would be a number that could divide the 25 and the 180? Well, that would be 5. 5 divides 25 and 180, and 180 divided by 5 is 36. So my answer here is negative 5 pi over 36. Please understand that we want these answers in multiples of pi. We don't want your answers in terms of a decimal. So these radians are exact measurements, and we want them done that way. Then we're going to multiply by pi over 180 here, and the best number to divide by here is probably by 10. And if you do that, you'll notice you'll probably not be done, because that would be 10 and 18. And we can divide again by 2. So I probably should have divided by 20 at the start, but sometimes you just don't see it. So that would be 5, and this would be 9. So the answer for number 10 is 5 pi over 9. So what we have here now is we have to convert radians to degrees, which we actually did earlier on in this video. So let's just formalize this process. So if we have degrees divided by 180, and that's equal to the radians divided by pi, this means that we take our radian and we multiply it by 180 degrees divided by pi, we will get degrees. So the pi is simplified to 1, and the 6 divides the 180 using cross cancellation there, or really just simplification. 180 divided by 6 is 30. So what we have left in the numerator is 5 times 30. This is 150 degrees. Now some of you might be saying, but Mr. Anderson, I did a unit circle back in session 1, and I just looked up 5 pi over 6 and saw that it was 150 degrees. And I would say, good for you. That's exactly what the unit circle's there for. In fact, why don't you look up the negative 2 pi over 3 on that exact unit circle? What you might notice is maybe you should go positively in 2 pi over 3 and then, see how far that would go in the opposite direction. But instead, you can just take this and multiply it by 180 divided by pi. So the pi is simplified to 1. 180 divided by 3 is 60. So negative 2 times 60 is negative 120 degrees. And that's where you would be is if you went 2 pi over 3 in the clockwise direction. Okay, so what happens when you're not on the unit circle? Well, you can still take your 4 pi and multiply it by 180 divided by pi. Now, a few of you might be thinking, but I know the answer to this already. But in case you don't, let's just finish the process. Pi divided by pi is 1. 4 times 180 degrees, thanks to my technology in front of me, is 720 degrees. Now, for the few of you who knew that answer so quickly, let me show people how you did that. You knew that 2 pi was equal to 360 degrees, or 1 revolution. So therefore, 4 pi must have been double that. So doubling 4 pi gives you, doubling 2 pi gives you 2 revolutions, which is 720 degrees. Okay, so we're going to multiply this by 180 divided by pi. Okay, the first thing is that the pi's simplify. It is not quite apparent as to what you should divide by. In fact, the fastest way to get this problem done is to divide top and bottom by 12. But maybe that's not as apparent to you. So maybe you want to divide by 2, which makes this a 90 and makes this a 6. They're both even, so divide by 2 again. That's a 3, that becomes a 45. Now divide by 3, because 45 is divisible by 3. The 3 becomes a 1 and the 45 becomes a 15. So what you now have is 5 here times 15. And 5 times 15 is 75 degrees. Now I do want to highlight that all of these radians had a pi in it, which is a definite signal that we're converting to degrees. But you can also have the quantity of radians just in terms of a number. So one really good thing to know is how big is a radian? Just 1 radian. How big is 1 radian? Now you'll notice I haven't put any pi or any other modifier on this. So 1 radian, to convert that to degrees, would be then to multiply the 1 by 180 divided by pi. Now if you do so, the calculator approximation of this will be 1 times 180 divided by pi, which is 57.3 degrees. So it's a little bit less than a 60-degree angle, which means that if I want you to go 6 point, now some of you know where I'm going here, right? If I want you to go 6.28 radians, how many degrees would that be? Well, let's multiply 6.28 by 180 degrees divided by pi, and you get an approximate answer of 360 degrees. There's about 6.28 radians inside of a unit circle, but 6.28 radians is another way of saying 2 times 3.14, and 3.14 is another way of saying pi. So 2 pi radians is equal to 360 degrees. It's very important to keep these relationships over here in this little box I've cut away fresh in your head, because if you have 1 radian, you're about 60 degrees, a little bit less. And since you're a little bit less than 60 degrees, you need more than 6 radians to get to a full circle, roughly about 6.28 radians, which is roughly 2 pi, which is 360 degrees. Oh, I'm hoping that radians are no longer a puzzle, but, you know, it takes a little bit of time to adjust from understanding in degrees to radians. Well, thank you very much for watching this video about degrees and radians.